Okay, first up, what I want everyone to do is to go to, are we seeing my screen first up?
I am seeing Julian Doherty's screen.
I see a big 100% on the screen. Yeah.
Okay, excellent. So go to that website there. I want to get my, how do I get my normal screen back? Help me out, Zoom. Yeah, so bossclick.madlib.com. I want everyone to go there and to start clicking, like just keep clicking. I will paste it in there when I can figure out how to paste the thing. Yeah, okay, good. Going. We're fighting. Keep fighting. Go, 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 go. So yeah, what we're doing here is basically everyone is in the room clicking. You're all clicking together. So I can click too. And we're going to click. And the faster we click, the faster we beat the boss. And we're going to click. Keep going. Keep going. 50%. We're doing good. More. Come on. You can do it. You can do it. You can all do it. Go, 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 go. 10, 5. Nice work. We win. Okay, cool. We fight the boss and we can go and fight it again if we want to. Yeah, so that was just a little throw together app that I put together. So I will just walk through what that thing is doing. So this was a talk that I did for a, basically it's for a front end code party at work where there's a whole series of lightning talks. So it's basically the talk was, okay, let's have a look at the front end code for this. There's none. End of the talk. Any questions? Yeah, then it kind of went more than that. It was mainly to troll the JavaScript developers. They didn't think it was that funny. But anyway, what we'll do is we'll have a little talk through what that whole thing there does. So the idea being it's a LiveView app, and yeah,
sorry, would you mind just zooming in a bit?
I will make that bigger.
See anything? Thank you.
And actually, I'll hide that thing, and I'll hide that thing. How is that? Is that more readable?
Yes, thank you.
Okay, cool. So how do we work? So I'm going to go through and just step through it. If you've seen LiveView before, you're probably not going to get anything new out of this, but we'll have a little walkthrough. So it's this plain old Phoenix app. Entry point there is going to be the application, which is something that'll be when you generate a new Phoenix app. This is what you get. If you generate a Phoenix app with the live switch, you get something that looks kind of like this. The bits that are interesting here, we've got our endpoint, and we're also setting up a boss as well, which we'll come to in a minute. Our endpoint is just a pretty vanilla Phoenix endpoint for how our web is exposed. The only bit that's slightly different with a LiveView app is you get a live socket set up in there as well. So again, this is just the boilerplate stuff that gets generated by, generating a new Phoenix app. Then we'll go into our router, and so rather than having like just a regular resource or a get or whatever, we've got a live route that's set up in there. And in this one that's set up in the root path. So if you go to slash, which is this here, that's what you get. So that goes and hits the boss fight live module, which is this one here. And that uses Phoenix LiveView. So what'll happen when that thing runs is it'll call the mount method. First thing it does when you mount it, we don't care about the params or the session. We're not doing anything with that at the moment. We just go off and we subscribe to the global pub sub for this fight. So every time you click it, that'll all go through to everyone else. And what we do is we get the current state of the boss just by calling boss current state in there. When that there returns, that'll then go off and render the LiveView template. And this is just exactly what we saw. So the HTML that got generated on there, we've got a bit at the top there saying click to fight the boss. That's in there. There's a button. And then we generate an SVG in there. And that will then draw this big red thing there. Anything that's slightly interesting, it's got a couple of gradients. And then it draws some rectangles to show the actual boss health bar. The interesting bit is that the size of the red bar is fitted in there based on the percentage that's being shown, and the actual health is shown in there as well. So that comes out of the template. The cool thing is if you turn JavaScript off and render this page, that's exactly what the HTML on the page looks like. So that's literally in there. If you wanted to run this whole thing with JavaScript turned off and keep refreshing the page, it doesn't work for the button clicking, but you could make it work by hooking it up with a form submission. But you will get the actual current state of what that thing is doing. So if people were clicking through, and then you go and look at the source again, you're going to get this set to, whatever the current state of that thing is. So the cool thing about LiveView is it'll let it work even if it'll degrade that way, which is kind of nice. So to get this thing, what we're doing then is when you do click the button, that's set up with an phx click attribute with an attack value. And what LiveView will do is wire up some stuff inside there to say, okay, when you click this button, connect over the WebSocket, send a message that basically is saying attack in there. And then back in our LiveView code, we've got a handle event function implemented, which will listen for that there. So we're saying, okay, when we get the attack message, do a thing. And really all we're doing is saying, get our boss and do 1 point of damage to it. And then we do a no reply and just pass the socket back to keep that state going. And that'll trigger another re-render of this page here on every client. Actually, no, sorry, on your client. So when you click it, that'll happen. So what does that do when you go to boss damage? So digging into this thing here, this is getting into an actual business logic thing. And this basically is set up for a gen server. So it spawns another process, registers it with the name boss server, so that when you call into this, it'll just find the same thing every time. I've got a better version of this code that kind of sets it up with the registry, so you can have multiple bosses potentially running with different names, with different people fighting different bosses, but it's not quite ready to show off yet. So the bit that's interesting is when you do damage to it, we've got this damage function here that we've implemented, and you just pass in the amount, which will be 1 point, and the server, which will be just whatever server is the process registered with our boss server name. And we just default to that, so you can call it like that there. You don't have to actually provide the name to the server because it's kind of implicitly registered as like a singleton that way. And that'll do a cast to actually send that message into the server. So the way this is set up is a little bit different than how you might have seen gen servers before. Quite often what you'll get with the gen servers have everything kind of all in one file. So you have like the public interface, which will be like our current state and our damage functions. Then you have all the callbacks for the gen server inside there, and then you might have your business logic intermingled in there, or you might have business logic separated out into a different thing. I kind of like doing a slightly different approach to that, where you have like one function or one module that implements the gen server interface, and this will have the init, does the handle call to get the current state of the boss, and a handle cast to get the damage. And then that sets up some other stuff to like do a heal. Every 250 milliseconds, it'll heal the boss by 1 point. So if we click here, and then eventually that'll heal itself back up again. And that's just doing it by, after every 250 milliseconds, it just sends a message saying heal to itself, which then gets picked up here in the handle info, and then that'll trigger the same message again and actually give 1 health point back to the boss and then send that back out into the world again. But there's no, try not to have any business logic in here. This one's got a bit, I've got some refactored code that's a bit better, but yeah, that's not quite ready. But what this does is then delegates off into an actual state module here. And this is the thing that actually contains all the data. So it's got the health, the max health, state of whether it's alive or dead. But it doesn't have any gen server stuff intermingled in here. This is just business logic. This one is just the gen server interface, and this one here is the public interface. So they're kind of three things that make up the same thing. And this is the same thing that Dave Thomas talked about. He's got a really good article on this called Splitting APIs, Servers, and Implementations in Elixir. It's kind of based on that there. So you have three modules. One's the public API, one's the gen server interface, and the other one's the internal business logic. And it's also kind of similar to having like a functional core imperative shell, where you've got your functional core with all the bits inside that drive the thing, and then your imperative shell is basically the gen server. So I just kind of like to do it that way. Makes the state easier to test as well. So anyway, that does some stuff. Got some logic in there for respawning, logic in there for doing damage, for healing, and then figuring out if you've killed the boss or not. Where we get that back out to the world again is that every time we change something on the boss in the gen server, we broadcast the state. And broadcast state is just, again, talking to that Phoenix pub sub channel. So saying broadcast from the process we're in to our boss 1 channel. And our message is just going to be the new state of the boss. So essentially that's that data structure there. So it's the health, what's the current health, and is it alive or defeated? Because we're sending that out over a pub sub channel, back in our LiveView module again, that'll get picked up in the handle info. Because when we mounted our thing, mounted our LiveView, we subscribe to that pub sub channel. So we receive the boss state, and then we basically assign that into the socket. That then will trigger a re-render of this here, and that'll get updated values for the bits and pieces in here. So the boss health, boss max health, and so on. And yeah, that's the whole thing. So it's a pretty minimal app, and it's something that could throw together. There's a few hours work in there. Most of it was actually getting this SVG to draw, because my design skills are severely lacking, as you can see. I was very proud of the gradient. It's about as good as I can do. My wife's a designer. She thought it was pretty lame. And yeah, I think that's me. I'm done. The code, if you want to have a look at this, is on GitHub. So madlab /boss click. I'll tweet those out as well afterwards, and you can have a look at them if you want. So yeah, any questions there?
Is that separation of that article about splitting layers? I was reading something very similar in a book called a Prague programmer's book called Designing Elixir Systems with OTP by James Gray and Bruce Tate. So that might be, yeah. I was just wondering, did he refer to that being like a wider? I know it was Dave, so he could, he might have been the source of the whole thing. But I'm just wondering if that was. Splitting
Might be. I've got that book, and I've heard really good things about it, but I haven't actually read it yet. So I need to dig into that and actually see what they're talking about. But yeah, I think it's sort of come up a few times, and I think Dave Thomas has had a few different stabs at it. Dave Thomas has said a lot of different things about gen servers over the years, but that's one that kind of fits for me because it's fairly usable, and it's actually makes the code nice and easy to test if you keep the gen server logic very thin and just really passing things back and forth, and then keeping all the stuff that interacts with the world outside of the business logic.
I think it's a really good point, actually, because the three things being jumbled together is hard to deal with, even in the simplest of cases. Maybe for a hello world with one variable being updated, it's okay, but beyond that, it gets
the biggest problem is when it's all intermingled. So you literally have the business logic implemented in the gen server callbacks. Testing that is just pain. Because if you need to fire up a gen server process and get all that running and pass messages back and forth every time to test the thing, it's like I'd rather just have process that's like code that's plain old data structures and functions, and then you can test it that way, and then you wrap it up in a process to make it work in the real world. But you need, like a fairly small integration test to drive all that, and then you have some more detailed stuff that digs into the actual functions that can run really fast.
I'm glad that people are actually trying to give some patterns or ideas about this, because I did find my first really big OTP thing was the Mavlink thing that I did, and that was the amount of boilerplate around working out my supervisor trees and all that sort of stuff was very, it was a bit daunting. That's one of the things that is that probably held me back a while from using it. It's awesome now that it works and everything, fails and restarts and nice and stuff like that. But yeah, I'm glad people are trying to make some structure for that, because it's one of the things that we sell as being a benefit of the platform, but it has a pretty steep learning curve.
Yeah, I think there's a whole lot of complexity around wiring up the OTP side of things, which is a thing to get right all on its own, and you kind of don't want to have the complexity of the problem you're trying to solve in there as well at the same time. Like, I like to test those things in isolation because they are both things that are complicated and they can both go wrong in different ways. I'd rather have one set of things going wrong at a time.
Yeah.
I'd be interested to know, Julian. I mean, I've got a Phoenix app that I'm working on at the moment, and I'm too knee deep in trying to get my head around what's the right kind of OTP architecture for concurrency and all that sort of stuff. I've gone for ETS tables because I've got a fair amount of data that I'm wanting to manage from my gen servers. But in this case, you used state within a gen server. Did it cross your mind, or what's the decisions with agents? Like, because I haven't really kind of figured out how they fit in.
I mean, in that one there, that's a throwaway app, and it's essentially there is no state. Like, you start one of those games going, and then everyone clicks, and then a couple of minutes later, throws it all away and starts again. So Mac, and also it's just running on Gig Elixir on the free plan. So Gig Elixir is like Heroku, but it's for deploying Elixir things. And that one there, I mean, it doesn't have any state. So if it was needing to keep some things, then there's probably going to be some level of, figuring out what it needs to be persisted what's the life cycle of things. Also, what's the access to it? So, if, the typical thing with the gen server is it's going to be a single threaded bottleneck, potentially. So if you've got lots of processes that are going to read from that, there's an overhead there. So its tables could make more sense in that case. And yeah, there's a lot of things that it could depend on, but for this one here, because it was such a small throwaway thing, just putting it all on a gen server. But it's actually not reading directly from the gen server much at all. So I think about the only time where it does a direct synchronous call to there is when the page loads and it's first mounted to get the current state of what the boss looks like. After that, it's all using pub sub, so that's broadcasting messages.
So
it doesn't actually talk to that at all.
Their view.
Yeah. So each one of those web sockets is subscribed to that channel. And then whenever there's an update on the gen server, that all happens. When you do damage to it, that's a cast, so that's not blocking. And then that'll process those messages in its own time and then send a broadcast out once it's done the update.
Mm-hmm. Yeah, awesome.
Just a question, Cameron.
Yeah.
What are you actually storing in your gen servers in a Phoenix app? Because typically what we've found is we're storing most of our state, if not all of it, in the database. You might cache some things if there's some expensive calls, but largely you want to keep everything around.
Yeah. So basically what I'm working on, and I'd probably be happy to even do a talk on it, over the next month or two, I'm building my own crypto trading platform, which I've rewritten in, over the last 10 years in probably as many languages and never actually finished. And my current go at it is Elixir, which I'm having a lot of fun with, learning functional, as well as kind of the OTP and Elixir stuff as well. But basically I'm receiving a large amount of data over a WebSocket. So candlestick data and real-time event data from crypto exchanges. And that's got other processes that are analyzing that data, but it really is very ephemeral. Like, I don't need it for a long period of time. I only need a window of maybe 10 minutes worth. And if a process goes down, when it comes back up, it can obtain that from the API anyway, and then keep it up to date with the socket connection.
So you're just keeping an ephemeral projection of everything that's happened for aggregation and summarization.
Exactly. Yeah, that's right.
Makes sense.
Initially, I started off actually having it all stored in timescale DB, Postgres's timescale time series data extension, and that was all written in Go. But it was just so much data going into the database and coming out of the database that it was actually getting really heavy on I/O. And in the end, I was wanting to actually clean up those tables and keep them quite small, beyond like a window of an hour anyway. And I just thought this actually makes sense to just be in-memory data.
Yeah, there's an app that we've got at work that I'm kind of working on upgrading the dependencies at the moment because it hasn't been touched for about 4 years since it was put into production. And that stores everything in ETS as well, and mainly because it's essentially static data. So it sort of has a bunch of stuff that gets built offline and sort of pulled out from various sources. Then that gets dumped as CSV files into the app, and then it loads it up and puts it all in its tables, and then it does the thing. So the only time the data changes is when the app gets deployed. and then it can just, put it in ETS and memory, and then, yeah, there could be a way to optimize it even further by, sort of processing it and then spitting it out into like an Erlang term format, or, you can have it compiled into the code even, which is kind of cool in the recent version or two of Erlang, which is nice. You have persistent terms to do that.
Yeah, cool.
But it's got to be things that are essentially static and don't ever change, because there's a huge overhead in updating that with garbage collection and so on.
Yeah. It has been actually, I found, quite easy to work with the ETS tables. Like if you compare it to the amount of boilerplate you might have when you're, talking to a database, I mean, all right, the repo pattern inside Phoenix is very convenient. So it's not like it's a lot of hard work to pull data out of a database, but ETS is actually quite easy, and you're kind of getting your data out in exactly the data structure that you want it, because that's how you've stored it. Like I transform it on the way in, and then it's easy to get out and work with.
Cool. Any further questions for Julian?
Just to comment on the timescale stuff with Postgres, if you really do need very high write speeds, you can disable the write-ahead log. There is increased risk of data loss and possible corruption, but you can get dramatic speed improvements. So if that is something that might help you.
Yeah, it's interesting to know actually, yeah, because time series data is, it's almost like almost all data has got a time series nature to it, right? Time's an important dimension with data, but I guess in my case, it's just data that I don't really care about in anything longer than a half an hour, an hour's time. It's dead to me at that point. So
yeah, so you could disable the write-ahead log on that. I think you can do it on table by table. If not, you might be able to create a table space that you disable the write-ahead log for, and then I think there's an increased risk of corruption which you'd have to guard against, but you could possibly partition the table as well, which is a hell of a lot easier in the certainly within 11, which I think what's 11. I think they've dragged their feet on 12 a bit, but so that those are things that you might want to look into. They might help.
Yeah, cool.